Hello, welcome to Physics Meal, a beautiful program designed for beautiful and handsome people like you, for us to improve in the study of physics. Remember, Physics Meal is part of Mathematics and Science Meal program, where we prepare delicious meals in mathematics and in sciences so that our students will remain healthy in sciences and also in mathematics. All right, today on Physics Meal, we are going to look at simple machines, part 2. We have looked at the first part where we consider the meaning and examples of machine and also the concept of mechanical advantage. So today we're going to look at two important concepts also. So our objectives are for today. By the end of the lesson, the students should know the following: 1, concept of velocity ratio of machines, and then concept of efficiency of machines. There's need for you to subscribe to our YouTube channel. Just hit the subscribe button and also follow us on Facebook. That's Mathematics and Science Meal. All right, let's begin this wonderful journey. Just stay away from every form of distraction. Anything that will distract you, please stay away from it, because we want to enjoy our meal without distraction. All right, let's begin. We'll look at the first objective. That's the concept of velocity ratio of machine. So let's look at that. Velocity ratio of machines. All right. Velocity ratio is one of the terms that will come across in the study of simple machines. Yeah, it's a very important term as far as machine is concerned. Now, we know that in a machine we have an applied force we call the effort that we use to overcome another force we call the what? The load. Now, the effort applied in a machine will move a certain distance. The same way, the load will also move a certain distance. Let's take, for example, you want to draw water using your wheel. Now, when you descend the bucket into the well, now as you turn the wheel, that's the effort arm. That's the distance moved by the effort. The effort is rotating through a cycle. Now, as you are turning it, that's the distance moved by the effort. Now, the bucket of water needs to travel through a certain distance. Remember, the bucket of water now is the load. So, as the effort is moving through a certain distance, the load is also moving through a certain distance. So, this distance moved by the effort to the distance moved by the load, that's what we refer to as velocity ratio. So we define velocity ratio as follows. Velocity ratio of a machine is the ratio of the distance moved by the effort to the distance moved by the load. So the ratio of the distance moved by the effort to the distance moved by the load. That ratio is what we call what? Velocity ratio. So velocity ratio of a machine is the ratio of the distance moved by the effort to the distance moved by the what? By the load. All right, that's velocity ratio. Velocity ratio of a machine. Now, if we now write it mathematically, so we can say velocity ratio, distance moved by effort divided by distance moved by load. So if we abbreviate velocity ratio, if we use VR as velocity ratio and we use X as distance moved by the effort and Y as distance moved by the load, then it means that velocity ratio will be X over Y. You can call this equation 2. Remember, in our last video we established the first equation, mechanical advantage, as the force ratio is equal to load over what? Effort. So here VR here is velocity ratio. X, distance moved by effort, and Y, distance moved by load. All right, so we have this expression. So when we know the distance moved by effort and we know the distance moved by load, just divide them, then you get your velocity ratio. Now velocity ratio, like mechanical advantage, is also dimensionless. It's also dimensionless. It has no unit. It has no unit, because if we say that VR is distance moved by effort over distance moved by load. Now the SI unit of distance is meter. Distance moved by load also is in meter. So you see, velocity ratio has no unit. Just note that. So when we calculate velocity ratio, there will be no unit assigned to it at the end of the calculation. Okay? So let's just mention that velocity ratio has no unit. It has no unit. Very important. Now, each machine has its own velocity ratio. We're going to list the velocity ratio of various machines. So we need to take note of that now. The velocity ratio of various machines. So velocity ratio of some machine. So every machine has its own specific velocity ratio. Velocity ratios of some machines. What's the expression for velocity ratios of some machines? So we have 1. The velocity ratio of pulley. Velocity ratio of pulley system is equal to the number of the pulleys. So the velocity ratio of pulleys is equal to the number of what? Number of pulleys. So if you have a block and tackle system, that's a pulley system containing 4 pulleys, it means that the velocity ratio will be equal to what? 4. So in pulleys, the number of pulleys is equal to the what? The velocity ratio. That's very important. Okay? 2. For inclined plane, the velocity ratio is given by VR plus 1 over sine theta for inclined plane. That's one expression for inclined plane. The velocity ratio for inclined plane is 1 over sine theta, where theta is equal to angle the plane makes with the horizontal. The angle the plane makes with the horizontal. So if you have a plane like this, you have a plane, an inclined plane. Have an inclined plane. Yes, sir. Have an inclined plane like this. This is an inclined plane. Now we look at this. This is the length of the plane, and this is the height. This is the length, this is the height. Now this plane will make angle theta. So the reciprocal of the sine of the angle that the plane makes with the horizontal, that's what gives us the velocity ratio of inclined what? Of inclined plane. That means if we are not given this angle and we are given the length of the plane and the height, we can also find the velocity ratio. Similarly now, still on inclined plane, similarly, we can also write the velocity ratio, or we can also express velocity ratio of inclined plane as follows. Let's explain that. Let's express that now. Velocity ratio of inclined plane can also be L over H. So I can call this equation 3 and I can call this equation 4, where L is length of the plane and H is height of the plane from the horizontal, the height of the plane from the horizontal. So if we have the plane like this, that's the length as I've drawn before, and then if this is the horizontal, then this is the height. So the length over the height. No wonder it's actually the reciprocal, because if the angle is here, opposite over hypotenuse is sine, but when you turn it the other way, hypotenuse over opposite will now be 1 over sine theta there. All right. So we have another machine, the third one. Let's talk about wheel and axle. The velocity ratio of wheel and axle is given by VR equals R over R. Can call this equation 5, this equation 4, where the big arrow is radius of the wheel and small arrow is radius of the axle. Wow, I believe that you are enjoying the whole thing. I know you are enjoying it. So we have various expressions for velocity ratios of machine now. So let's take one more machine, and that's going to be screw jack. The screw jack. So let's look at that. For a screw jack, what's the velocity ratio of a screw jack? So let's look at that now. Velocity ratio of a screw jack. That's the fourth note now. Velocity ratio of a screw jack is given by velocity ratio equals 2 pi r over p, where p is the what? Is the pitch. Is the pitch. Is the pitch. Alright? P is the pitch. P is the pitch. So you know how a screw is. You know how a screw jack is. You have that. So this distance here, that's what we call the pitch. The pitch. So where P is the pitch. Now VR now is the 2 pi r over this. So r is the radius of the screw. You know, you have a jack, the one you use in lifting a car when you want to maybe change the tire of a car. That's it. So you have what you use to jack it up, the jack itself. Then you turn the handle. So the circumference of the handle, we know the circumference of a circle is this. So the circumference moved by the handle, that's the distance moved by the effort over the distance moved by the load. Because once you turn this, the load moves upwards through by a space of the pitch anyway. So that is the velocity ratio of screw jack. So we have velocity ratio of wheel and axle also. We have velocity ratio for inclined plane. We have all the velocity ratios of the common machines that we are going to consider. All right, I believe that so far you have mastered everything about the velocity ratio of a machine. We are going to take a short break, and when we return, we're going to look at the concept of efficiency of a machine. Don't go anywhere.